Now we are at part 3, and let us look at this method called Patara or Prastara, I think, what they are trying to do. Here they have 4 spaces, and then 4 spaces with 2 syllables. It could be sa, re, or something like that. So we have a curved one and a line. Let's call it curve and line. So in 4 spaces we could have all curves, all sas or all re's, whatever. Sarigama Padamisa. So we have having all 4 locations with curves is only one way that you can do that. And then they have 3 curves and one line, so that you could have 3 curves and 1 line, or 3 curves and another curve, in which we already used. And then next one is 2 curves. If you have 2 curves here, and it could be a line and a curve, or line and a line, and you cannot have 2 curves again because we use that again. So basically these are the methods that they can do, and how many, there are 16 ways of doing this. How to find that? You could do, so the first location have 2 different ways, second location 2 different ways, and you would get 16, but you have to expand it. So that they did with the expansion here, and they obtained 16 here. And then the next one is algorithm called Natta, and it more related to poetry more than mathematics, so I'm going to skip that. And then we have something again, Uddita, and again there's not much mathematics per se, so it's mostly poetry. And then this one is important. It goes into the Pascal's triangle or Meru Prastara of Pingala Guru Kriya, and see what they do here. And the question here is curve and a line, and they ask the question, now if you have 4 places, how many, if all 4 syllables are curves, and how many ways you can do that? It will be 1. And then number of forms with 3 curves and 1 short would be 4. How did they get 4? Let's look at here. So all curves could be only one way. 4 curves in only one way in four locations. That's very clear. Now if you have 3 curves, and then you could have a 1 line here, that's a 1 way, and you could have 3 curves here and another line here in the second way, or you could have 3 curves here, 2 here and 1 here, one another curve, so line, that's the 3rd way, and 1, and this is the 4th way. So there are 4 different ways. And similarly, what if you have 2 curves and 2 lines? You could get 6. You could draw it down and see how many you get. It would be 6 numbers. And then 1 curve and 3 lines, that will be again same as this one, will be 4 numbers. Now all 4 are lines, there's only 1 way. Now if you look at these numbers here, 1, 4, 6, 4, 1, that's basically Meru Prastara, Pingala's Meru Prastara or Pascal's triangle, remember? 1, so if it's 1 location is 1 and 1, second is 1, 2, 1, third, if you 4 is 1, 4, 6, 4, 1, and that's what you're going to get here, 1, 4, 6, 4, 1. So this is Pascal's triangle or Meru Prastara that they obtained from Pingala. I mean, this is not new to the Indians. What is my conclusion of this paper? I don't think there's any new knowledge is shown beyond Pingala's Meru Prastara. I mean, it just shows that they knew about Pingala's Meru Prastara and they applied it to Sinhalese poetry. And I don't see anything beyond that. And there is no indication of knowing the binomial coefficients related to solving equations. These coefficients. So if you want x plus y squared, then you could use this to solve this equation. That's what these coefficients are there for: 1, 2, 1, 1, 3, 3, 1, etc. But there is no such thing as solving equations here. So the word binomial coefficients is not correct. I mean, we should not be using it. Probably Pascal triangle or Meru-Prasthara would be better, because there is no equations to solve, and they didn't solve any equations. So that is a wrong misnomer in this paper. It should not be called binomial coefficients because there are no equations. This better use would be Pascal's triangle or Meru-Prasthara. Now, Pascal triangle is used to find binomial coefficients. Binomial means two terms with the power series, and there is no such knowledge expressed here. But even though there is nothing new to the world in this work of 12th century in Sri Lanka, that we obtained Pingala's work and we applied to Sinhala poetry, but there is no advancement in mathematics. But nevertheless, in the world stage, only few countries would have had more advanced mathematics at that time in 12th century. China, India, Greece. I don't think rest of the Europe had any advanced mathematics as shown here. So this is my conclusion. Thanks a lot for listening.